Okay.
We are live now.
Awesome. Well, hi guys. My name is Divya from DoraHacks. I'll be the host of today's Fuel Sway Summer Hackathon Workshop number one. First of all, I'd like to thank both the Fuel team and the audience for joining the workshop. Today's workshop will be hosted by Sarah, who is a front-end engineer at Fuel Labs. The title of the workshop is Introduction to Sway. We'll cover the basics, a little bit technical too. And so, yeah, so Sarah, thank you so much for taking the time to run our developers through Sway. Was I think they're ready and super excited to be here today and learn a little bit more about what you guys do at Fuel. So take it away.
Yeah, thanks so much for the introduction, and thanks so much everyone for joining. I'm really excited to be here and to walk you through your first Sway contract. So really quick about me, I'm a front-end engineer at Fuel Labs, but I also used to be on the developer relations team. So I've worked a bit with Sway. So just before we begin, a quick overview of some Fuel terminology that you'll find really helpful is when I say Fuel, I'm referring to the Fuel blockchain or the Fuel network. Sway is our Rust-based domain-specific language. Fork is essentially the equivalent of cargo for Rust or NPM for Node. It's short for Fuel Orchestrator, and you'll use it to create a new project, to build your contract. You can use it to deploy your contract, and you'll be using it a lot. FuelUp is the Fuel toolchain manager, and it's essentially what you use to manage and update your versions of Fork and Fuel Core and other tools. And then Fuels, which is just Fuel with an S, is essentially the equivalent of like Ethers.js or Web3.js, like for the TypeScript side, but they're basically both of our SDKs. So we have a TypeScript and Rust SDK, and they're both called Fuels. So it's sort of what you use to interact with a contract. And a quick overview of dApp architecture on Fuel. So if you're coming from building in the EVM, you're used to using Solidity, and probably for developing and deploying, you probably use like something like Hardhat or Foundry. For SDKs, like I mentioned, Ethers.js, Web3.js, and for the indexer, you could use something like the Graph or build your own indexer. And all of these tools are sort of independently built and maintained. And I think that's a huge difference from building on the Fuel network, is that all of our these tools are replaced with in-house Fuel network tools. So we have Sway as our language that we use to build contracts. Instead of having to use Hardhat or Foundry, you can use FuelUp and Fork. It has all the tooling you need for development. We have our own SDKs for Rust and TypeScript, and we also have our own indexer system. And just like a brief overview of some major differences from Solidity and Sway is that Solidity is that OG language for the EVM. It's been there for us for a lot of really cool projects, but it's also sort of been there for us for a lot of not so cool things like big hacks, and it can sort of feel like a minefield for vulnerabilities when you're building, because you're not 100% confident that the code you're writing is going to be secure. And contrast that with Sway. Sway is based on Rust, and it's essentially if Solidity and Rust had a baby, it would be Sway. It was built with lessons learned from Solidity in mind, and it has a lot of the sort of things you would expect from Solidity, useful things, I guess. And then, but it also has that like really safe feeling of Rust, where there's a compiler that will give you really specific errors and tell you, oh, you're missing, something here on this line. And it was really designed to have a great developer experience. So a few dependencies you'll need to start building on Fuel is the Rust toolchain, and you can go to rust-lang.org to install, and it should be a pretty quick process. And then same with FuelUp. So if you go to github.com/fuellabs/FuelUp, You can scroll down and see in our README, we have this one simple install command. And you can also find this, our website is install.fuel.network/latest. And you can also find the installation steps here. And so, yeah, it's just one command, and this will modify your path for you. So if you prefer to not modify your path, there's another command. But yeah, should be just running this command, pretty straightforward. And once you have that installed, you should be able to, I'll make this a little smaller, run fuel up show. And this will show you all of your installed tool chains and what active tool chain you're using. So I think by default, it will install the latest tool chain, but for this demo, I'm going to be using the beta 3 tool chain. And essentially, these tool chains align with our different test nets. So if you want to deploy to the beta 3 testnet, you'll have to use this beta 3 tool chain. And but for example, like let's say you don't care too much about deploying to the testnet, you're okay with running it locally, which for the purposes of the hackathon is totally fine, doesn't make a difference. You want to use our latest features, you can use have the latest version here set as your default. But I'm going to use the beta 3 version. So to install that, the command is fuel up toolchain install beta 3. Let's see if this works. And I already have mine installed, but this would be the command that you could run to install that one. And just installing it doesn't set it as your default, so you have to run one more command, which is fuel up default beta 3. And you should get this confirmation that the default toolchain is set to beta 3. All right, so now we have our dependencies installed. We're all ready. Let's create a new project. So I'm going to use fork new, and then whatever we want to name our project. So I'm just going to call it contract, and this will create a new like template sway contract for us. And I'm going to go into that contract folder and open it up in VS Code. Okay, so the first file you'll see here is fork.toml, and it's essentially just a configuration file for your project. So it has like your author name, the name of the project, and you can configure different settings here if you want. But we won't be doing too much with this. And we have a gitignore file, and then we also have a source folder that has our contract in it. And this is called main.sway or main.sw. And let me make this text a little bigger. You can see. Okay. So the first line of the contract is just this keyword contract here. And the reason why we have this is there's actually 4 different types of programs you can write in Sway. So you can write a contract, you can also write libraries, and you can also write scripts and predicates. And I'm not going to go too deep into what those are, but essentially a script is sort of what you would think it is. It's sort of like a script you can run, and a predicate is sort of like a function that evaluates to true or false that can sort of lock tokens in an address and conditionally release them. But we're going to be focusing on contracts today. So yeah, we have this contract keyword, so we can just leave that in. And then we have 2 sections here. We have an ABI, and then this section that essentially is implementing the ABI. So the ABI in a Sway contract is basically like an outline of all of the functions and their inputs and outputs. So this contract has one function you can call called test function. It doesn't take any inputs, and it returns a Boolean. And that's all that goes in the ABI. And then down here, we're implementing this my contract ABI as a contract and implementing the logic here. So this one's really simple. Essentially, this part of the contract, you just copy and paste. It's exactly the same. And then inside the logic here, we're returning true. So this actually is equivalent to, say, return true with a semicolon here. But it's sort of a shorthand for returning something in Sway. So you can just, if you omit this semicolon, then it will just return whatever is in this last line here. So yeah, let's get started building a really simple game. So first, I'm going to change the name of this. So instead of my contract, let's call it my game. And you can see that the editor is already mad at me because it's saying, okay, I'm trying to implement this my contract ABI, but I don't find it. So we need to update this as well to make sure it matches. All right. And inside our game, we're going to have players. So to sort of visualize like what is a player, we can use something called a struct. And if you're coming from JavaScript, a struct is essentially like an object, something that has key and value pairs. So our struct can be called player. And it's going to have a level to it. And this level, we need to give it essentially a type here. So the level is going to be a number. And in Sway, the default number type is U64. So this is an unsigned integer that goes up to 64 bits. And then we can also have a player type. So the naming convention for naming variables and functions in Sway is using snake case. And the player type is going to be an enum. And we can say just like this player type. And then to create that enum, use enum keyword, player type, and it looks a lot like how you would set up a struct. And there's going to be two types of players. We're going to have a superhero and a supervillain. So you can say superhero, and these also need a type, but we can just give it a unit type, which is sort of like a blank type for now. So essentially, there's just a superhero, which is sort of just use the text to identify that, and then a supervillain. Okay, so now we have our idea of like what a player is. It has a level with a number, and it's either a superhero or a supervillain. But we can also add functions to this struct. So we can, just like we're using this implement keyword to implement ABI as a contract, we can implement this player and give it some functions. So essentially, it's sort of like you're familiar with like classes in JavaScript. It's the idea of like object-oriented programming. You can contain all the logic of this player within this struct. So we're going to have a function called new, and we can use that to instantiate a new player. And all the players are going to start at the same level, but there's going to be different player types. And so we're going to use a player type as a parameter here to decide what kind of player we're creating. And this function is going to return a instance of the struct, so we can use this self keyword here. And then to actually implement the logic here, we can return the type self. And we can just say the level is 1 and the player type is this player type parameter we have here. Okay, so we have a level. Let's create a function to level up the player. So we want to increase the level. So here we can say function level up. And this function, instead of taking a parameter, it's going to take sort of like itself as the first parameter. So we can say ref mute self. And what this is doing is we're saying that we're referencing ourselves here. So it's going to reference whatever instance of the struct this is. And this mute keyword means that it's going to be mutable. So we're going to be mutating ourselves, like mutating the struct. And we can have it return the new level for the player. So that will be U64. And then to actually change the level here, we can say self.level plus equals 1. Or we can also say self.level equals self.level plus 1. And then finally, we want to return this new level. So we can say self.level. And leaving out this semicolon returns the value here. Okay, so now we have a player and we have some functions. We can create a new player and we can level it up. Let's actually add this to our contract. So we just have this test function in the API right now, but let's create 2 functions. One is going to be called new player, and we'll have it return a player type. And we're going to add another function called level up. And it will return the level. Okay. So let's start implementing these functions. So we can just copy and paste what's in the API here and replace it with what's here, and replace these semicolons with curly brackets. For now, we'll just return 0 for this one, so leave this alone for a sec. And okay, so new player. We want to create a new player, and we have this struct, but where are we going to store all of our players, essentially? So Sway has something called a storage block, and this is really different from Solidity, where you can sort of declare a public variable almost anywhere inside a contract, and it will be a persistent variable. But for Sway, all of your persistent variables go inside of this storage block right here. And if you declare any variable outside of here, it won't be like a persistent variable that anyone can access. So we want to store all of our players here. So we can call this variable players. And it also looks like a struct or an object where there's like key and values here. So all of the variables are going to be the key, and then the value is like the value of those variables. So in Solidity, you probably are used to something called mapping, and Sway has its own version called storage map. And it's a special map type that can only be used inside of the storage block. So I can't just create a storage map inside of this new player function. It has to be inside of the storage block. And the storage map is going to have key and value types as well. And we use this sort of generic syntax here, and we can just initialize the storage map as an empty storage map like this. The storage map keywords and empty brackets, curly brackets. So in our storage map, we're going to be saving essentially like a player's identity to their player struct. So we could use something like this, where we have address and then player as the type. But a big difference between Sway and Solidity is that this address type actually means specifically externally owned accounts. So that excludes all contracts. So if we were to do this, we'd be saying explicitly, we don't want any contracts to be able to call our contract and create a player. We're only allowing like a wallet address to be able to play our game. So let's say we don't care, and we don't care if a contract plays our game or if it's just a regular wallet or not. We can use a special type called identity. And an identity is basically just an enum of the address and the contract ID type. So on the other side of it, let's say we only wanted contracts to be able to play our game. We could do something like this, like contract ID to player. But because we don't care, we're going to say identity here. So, all right. So now we know where we're going to store our player. So how do we get this identity though? So similar to Solidity, there is a message sender function you can use. But instead of it being like a global variable, you're actually going to pull this from our standard library. And if you're used to Rust, you know what a standard library is. If you're coming more from the front end side, like JavaScript or React, it's sort of similar to how you can pull in use effect or use state from React. It's sort of something that's there out of the box, but you have to explicitly import it to use it in your program. So we're going to say use standard, and it has these like 2 colons here and these curly brackets, and then we can import whatever we need from the standard library here. So we're going to be importing a few things. So we're going to be importing from the call frames standard library, or call frames library within the standard library. And oh, sorry, that's a different one. All right, we're going to be importing from the auth library. And it's just this message msg underscore sender. So auth and then 2 colons message sender. And we need a semicolon here. Okay. So now we have a message sender, a method that we can call. And in our function here, we can say let sender equals message sender and call that method. And then we're also going to unwrap our result there. And it's angry at us right now, the LSP, because we haven't returned a player yet. But essentially what this is doing is getting whoever is calling the function and unwrapping the result. And the reason why we're unwrapping it here and we don't just get this straight away is because there are some edge cases where the message sender isn't able to be determined. So this function is actually returning a result that could be like, either it has the result or it doesn't. So here we're saying, by unwrapping it, we're saying we're assuming that we're able to get the message sender value correctly. And in most cases, you will be able to, and you won't have to worry about this. And so this sender is going to be an identity type, so that's exactly what we need. And the next thing we need to do is create our player, right? We need to create the player and then add it to the storage, and then we'll finally return it. But in order to do that, we need to decide what player type it is. So one way we could do this is say that if the message sender is a address type, it's just like a wallet account, then it can be a superhero. And then if a contract is calling our contract, then that can be a supervillain player. So the way we can do that is say let player type equals, and then we can use this match keyword. And this will essentially allow you to match all of the possibilities of what type sender could be. So we know it's an identity, but what type of identity? Is it an identity of an address? And if so, then this player type is going to be of type superhero. And then on the other side of that, you just copy and paste this. If the identity type is a contract ID, then it's going to be a supervillain. Okay, and now we have our player type, we can create the player. So let player equals player new, and then pass in this player type. And finally, return the player at the end of the function. So we want to add this player into our player storage map. But in order to do that, we need to actually add a couple annotations to our functions. And so first we have to go up to the ABI, and we're going to add this special annotation here. It looks like this. It's like a hashtag, square brackets, and the keyword storage, and then in parentheses, write. And what this is doing is giving explicit permission for this function to write to our storage block here. Right, so all the persistent variables are going to be here. So essentially, we have a guard for all functions. All functions are by default pure, so they can't read or write from storage. But with this annotation here, we can do that. So add it to the ABI, but also to this function here, right? And now we can actually write to storage. So the way we're going to do that is use the storage keyword here, storage.players. And what's really cool about this is all of the persistent variables in your contract are going to be namespaced. So they'll all, I could name this players if I wanted to, and it won't get mixed up with this variable up here. So I can say storage.players.insert, and then we're going to insert the identity and the player. So we have the sender and the player. And all right, yeah, that is our new player function. All right. And then finally, we want to level up. So this function is also going to access storage, and it's going to both read and write from storage. So I'm going to add this read keyword here. And just like in this function right here, we have, we're getting the sender with the message sender method. And we can look up the player with this identity since it's the key for this storage map. So we can say let player equals storage.players.get sender.unwrap. And if you're working on the latest toolchain, latest version of Sway, you'll notice that this works a little bit differently. And so that's why my code editor is kind of confused actually about like looking for this storage key, which is like a latest feature, which is a small bug we have. So you don't have to worry about that. But essentially, yeah, we're using this get method to grab the players with the sender identity. And then we're unwrapping it because this result could potentially be null or none. And we have this level up function we can call on the player, but we need to add this mutable keyword here to actually mutate the player. So we can then say player dot level up to actually level up the player, and this should return the new level. So we can say let new level equals player dot level up, and we'll return this U64 at the end here, the new level. And the last thing we need to do is add this storage annotation and then actually update storage. So right now we're leveling up the player locally, like within this function, but we need to write over the old instance of the player in storage. And the way we can do that is with the same method right here, storage.players, insert sender in the player, and this will override the previous value. Yeah, so that's your like basic, super basic game you can make with players and levels. We could add a couple more features here, actually. Another really cool feature we have in Sway is native assets. So instead of having to like use ERC20, contract and import that, deal with that, you can import from our standard library. We have a token library, and we have this function called like mint2. And this will mint tokens that are essentially the address of the token will be your contract address. And they're just essentially, it's like a really easy out of the box way to mint tokens. So let's say in our game we wanted to have some sort of tokens, and when you make a new player, you get some new tokens. So what would that look like? So we just imported from the standard library this token mint2 function or method. And then within this new player here, so we can save this at the end, we can call mint2, and this takes like the amount and then the identity of the sender. So if you want to mint one token, you use this, essentially it's like 1 billion, because that's sort of like the max number of decimals that you can use in Sway, and you can use these underscores like commas. And so we're going to mint essentially one token to our sender. And it's that easy. So now this function, when it's called, it will mint tokens. And so let's add one more feature here of like, let's say we wanted to make the player have to pay in the game tokens to level up. So we can add another keyword to this annotation here called payable. And just like in Solidity, it's for functions that you expect there to be a payment. And like anything, when you're updating the functions, you have to make sure you have to update the API as well as the implementation down here. So this function is payable right now, and we want to be able to have players send our token and only our token to be able to level up. So that's another cool thing about Fuel is you can directly send any token. So it doesn't use like a account or like a ledger balance essentially. And the way we can do that is we have a couple more methods from our standard library. So we have a message asset ID, contract ID, and message amount. I'm gonna copy these in here. So from our call frames library, we have message asset ID and contract ID. So this contract ID is going to fetch whatever the ID of this contract is. And message asset ID is going to be able to tell what is the asset sent in a contract call. And this message amount is also going to be able to tell the amount. So this is different from Solidity, where you can only really tell the amount because you're only able to send like Ethereum, for example, or whatever the base asset is. In Sway, you can send any asset. So you have to check both the amount and what the asset is. So down in our level up function, we want to check what is the asset being sent. So we can say let asset ID equals message asset ID. And then we can use a require statement to make sure, okay, does this asset ID, is it equal to the ID of this contract? And if not, we can add error message here. You can also create like an enum for errors. So I'm just going to use this as the error right now, but generally suggest like you can create an enum with all of your errors that could come up and use the enum type here. So yeah, so now we can make sure, okay, they're sending some asset and it's the asset that we minted to them. And so if we want to check also it has to be a certain amount, we can say let amount equals message amount and require that this amount is greater than 0 or else there's not enough tokens. All right, yeah, so that's our super simple game. And let's use fork build to build our contract and make sure we don't have any errors. Okay. Expected token. Oh, I see, I forgot. Let's see, let amount. Ah, see, I forgot the semicolon. See, the compiler's so helpful like that. So fork build. Forgot one more semicolon. Yep. And this is why it's actually so much like, personally, I really love building on Sways because little things like that, in Solidity, sometimes they're harder to find, they'll trip you up. And all right, so our contract's building fine now. And yeah, the compiler really is holding your hand throughout the process. So yeah, that is our Sway contract. On Friday, I will be leading a workshop to build a front end for this contract using our TypeScript and Wallet SDKs. So I really highly recommend you check that out. And if you want to find a copy of this contract on GitHub, I uploaded it to my GitHub. Here it's Sarah Schwartz / Sway Game Demo. And you can find the whole contract here. Thank you so much, everyone. If you have any questions, please go to our forum.fuel.network, and we'll be happy to help you. Thank you.
Well, thank you so much again, Sarah, for taking the time to run our developers through all of this. I'm pretty sure it was very valuable and informative. So thank you everyone else for being here. So feel free to check out the full workshop schedule on DoraHacks.io. And if you guys have any questions for myself or the field team, please contact them on their socials, Discord, same with DoraHacks as well. Or you can also reach out to me directly on Telegram on DIVYE8HH. With that being said, I'd like to give one last thanks to everyone who spoke, basically Sarah, and those of you who have attended and watched this whole presentation. This should definitely guide our developers in the hackathon. And yeah, so this concludes our workshop. Thank you so much, everyone, again for your time.
Bye. Thanks.
Bye.